So another part of our preparation toward this WAEC chemistry practical. Now here we want to look at how we can actually prepare most of the reagents that are needed for the success of this WAEC chemistry practical. Okay, we are asked to prepare 5 grams of the base, which is sodium triazole 4, and this is the base, sodium triazole 4 decarbohydrate. So we first of all take the measurements. Okay, this is our measuring or our weighing balance. Okay, I will on it. Okay, so we have it that I will first of all remove the weight of the container. Okay, now I can now measure the weight of the salt. You are asked to measure 5 grams of the salt. So let's see how to measure that. Okay, it's almost there. That is 4.15. You are close, or it's more than 5. You just take a small quantity of it out. Almost there. Okay, that is 5.00 gram of sodium triazole 4 decarbohydrate. Okay, now okay, now this is 0.102 mole per dm cube of my base, sodium triazole 4. Okay, now you can see the mark here. This is 1000 dm cube. Okay, alright, now the next thing I will prepare now is the HCl. What we need in HCl is just 8.5 gram per dm cube of HCl. So it's very simple to do that. Just measure 8.5 of the HCl and dissolve it in appropriate proportion of water. Okay. Off. Okay, so this is a well prepared of the hydrochloric acid. This is 0.101 mole per dm cube of HCl. You can see in the container this is 1000 cm cube, which is equivalent to 1 dm cube. We use this to measure that. You can see this, the mark here will give you accurate measurement of 1 dm cube, which is equivalent to 1000 cm cube. So our reagent is now what? Ready, and you can actually use it and work and get your what? Correct results. Okay, I can't wait to see you people excel in your various academic endeavors, especially tomorrow, which is your WAEC practical. Good luck in your exam. Hi, good afternoon. You are welcome to Covenant Knowledge Center channel. You are in the right channel. Here you nurture brains, you make chemistry easy for you. If you are a subscriber, keep following up. If you are new in the group, just click on the subscribe button. Today we'll be looking at this year 2023 WAEC chemistry practical, and I'm not saying that we are looking at the main question. This is just a similar question that you will see in your chemistry exam this year 2023. Okay, now let's start with the question on the board here. We are told that AN is 0.102 mole per dm cube HCl. B is a solution containing 5 grams per dm cube of triazole 4 decarbohydrates. Okay, that is the mole per dm cube of HCl, and that is also the gram per dm cube of the base. So this year practical is going to anchor us on a strong acid and a weak acid. Okay, now we are asked to put A in the burette and titrate against 20 or 25 cm portion of B using methyl orange as indicator. The reason why we are using the methyl orange is because it involves a strong acid and a weak base. And of course, if there is anything that involves a strong acid and a weak base, it's normally recommended we use methyl orange. Okay, now let's first of all anchor on the question first and see how to solve some problems. Then after, we look at the major table. Okay, now from your result and the information provided above, calculate concentration of B in mole per dm cube. Okay, let's see how to do that. We have our usual formula: CaVa all over CbVb equals to Na all over Nb. Ca is the concentration of acid. Yes. Va is the volume of acid. Cb is the concentration of base. Vb is the volume of base. Na is the number of moles of the acid. Na is obtained in the equation. The equation is given. Na here is 2. Now Nb is the number of moles of the base. You can see it here is 1. Okay. Now let's see. Ca is the concentration of acid in mole per dm cube. You can actually get that from your question. Look at it, there's 0.102 mole per dm cube. Okay. Now we have the Va, which is the volume of acid, 8.55 cm cube. That is the acid. That is your endpoint. That is the one you obtain from your table after finding the average theta value. That is Va equal to 8.55 cm cube. Okay, here is the Cb, concentration of the base in mole per dm cube. That is what we are asked to find. So that is why you are seeing the question mark there. Alright, let's look at Vb. Vb is the volume of the base that can be obtained from our burette. Okay, if you look at this burette here, our burette here is calibrated 0 to 25. Now we also have some schools calibrated 20.0 cm cube, but here we are going to use a burette that is calibrated 25 cm cube. So that is why you see the volume of the base here indicated 25 cm cube. Now here is Na, this is the number of moles of the acid, 2. Is in the equation, already shown you that. Now we also have the number of moles of the base, 1. It's also here. Okay. Now the next thing for us is just to substitute into our formula. Okay, here we have Ca 0.102 mole times Va 8.5 all over Cb times 25 cm cube equal to 2 all over 1. This is the number of moles of the acid and the number of moles of the base. Okay. Now if we make a Cb the subject of formula here, we are going to have 0.102 mole per dm cube times 8.55 times 1 is equal to Cb times 25 times 2. Okay? Divided by what? 25 and multiply by 2. Of course, if you do that, you are going to see that what you are going to have is a 0.102 mole times 8.55 divided by 25 times 2. If you just use your calculator and punch that, you are going to have 0.8721 all divided by 50. And if you do that with your calculator, you are going to have 0.0174 mole per dm cube. Now this is the concentration of the base in mole per dm cube. Now let's look at the next one is the molar mass of X2 in the question. Molar mass of X2CO3. Okay. Now we have a formula. If you are calculating molar mass, you don't just calculate molar mass anyhow. We have a formula. The formula is concentration in gram per dm cube is equal to the concentration in mole per dm cube times molar mass. Now we are looking for the molar mass here. So we can divide both sides by the concentration in mole per dm cube and multiply by molar mass. Okay, if you do that, concentration in mole per dm cube is going to cancel concentration in mole per dm cube. Now the molar mass, we are going to have concentration in gram per dm cube all over concentration in mole per dm cube. Now, concentration in gram per dm cube is gotten from the question. Look at it here. They say B is a solution containing 5 grams per dm cube of triazole 4 decarbohydrate. That is how we managed to get this 5 here. Now concentration in mole per dm cube is the one that we just calculated, 0.0174 mole per dm cube. So if you divide that, you are going to have 287 gram per mole. That is our molar mass of thiazocarbon-4 decahydrate. Now let's move to the next question. And what is the next question? Calculate the value of x. The value of x, this is the value of x we are talking about, the value of x in the equation. Okay. Now if you are calculating the value of x here, okay, it's very simple. First of all, we write out the molecular formula of the compound in question, S2CO3.10H2O equal to 287. Where is this 287 gotten from? The molar mass. You can see it here. Okay. Now, the next thing is you multiply each of the atom of the element by the respective element. Multiply the number of atoms by the mass number of that respective element. Okay, here we have here x. So you multiply 2 by x, 2 times x. You are going to have 2x plus here the number of atoms of carbon is 1. So you multiply it by the mass number of carbon, which is 12. You are still going to have 12. This mass is always given. Look at it here. You can see here Na is equal to 23, C equal to 12, oxygen 16, hydrogen 1, chlorine 35.5. So don't be scared. How will I know the mass number of the element? It's always given in the question. Okay, now the next one is plus 3. I choose to put this 3 in bracket because the number of atoms of oxygen. Then this is 16, this is the mass of oxygen, plus 10, the number of atoms of the number of molecules of water, into 2 times 1 plus 16 equal to 287. That is the molar mass. Okay, so 2x plus 12 plus 3 times 16 will give you 48, plus 10, 2 times 1 is 2, plus 16, you are equated to 287. Okay, here we are going to have 2x plus 12 plus 48 plus 10 times 18. If you do that, you are going to have 2x plus 240 equal to 287. And the next step is to make x the subject of formula. Here we have 2x equal to 247. Okay, so 2x equal to 247. So you divide both sides by 2, you are going to have 23.5. And that 23.5, if you are asked what is the particular element, the element with the mass number 23.5 is no any other element than sodium. That is why you are seeing me putting the sodium in brackets. Okay, now the last question we'll be looking at is okay, let's see the last question. Percentage mass of X in thiazocarbon-4 decahydrate. Okay, let's see how to calculate that. It's very simple. Okay, percentage of mass in S in thiazocarbon-4 decahydrate can be gotten by mass of X all over total mass times 100 all over 1. Now where is the mass of X? The mass of X is no other X than the one that we have gotten here already, 23.5. Yes, multiply it by the number of atoms of X in the question. Okay, let's see. Now look at it here. 2x, it was x2, so we have 2x here. So let's just be multiplied by what? 2. Now divide by the total mass, which is what? 287. Don't forget this mass, the molar mass, the one that we got here. So multiply by 100. Now if you do that, multiply 23.5 times 2, you are going to have 47 all over 287 times 100. So you multiply this, divide by 287, you are going to have 16.37%. So that is how we got our percentage by mass of X in thiazocarbonate 4.